of this unit has been various types of factoring. But we also talked about adding and subtracting polynomials and multiplying polynomials. So we're going to start with the adding and subtracting and multiplying. And then we'll talk about all the various types of factoring. And then we'll go through a couple of problems on the assignment together. And then the rest of the time will be yours. So when we are adding and subtracting compared to multiplying, they look almost exactly the same. These are two completely different problems, even though they look almost exactly the same. So what's the only difference between these two problems? One's multiply and one's subtract, but why?
Because on two multiplying the two parentheses are together, subtraction, there is a sign in between.
Exactly. On multiply, the two parentheses are touching. On addition and subtraction, there's a minus sign separating the two parentheses. That tells us to do these two problems differently. So when it's adding and subtracting, we always put a 1 in front of each parenthesis and distribute that 1 in. We have to get rid of these parentheses. And usually we get rid of parentheses through multiplication, but since the parentheses aren't touching, I can't multiply what's inside the parentheses. So I distribute the 1 in. When I distribute a positive 1 in, what's going to happen to this first one? It's going to stay the same. 2x squared minus 5x, nothing will happen to the first one, except that we get to drop the parentheses. But if there is a minus sign, that makes a difference. Negative 1 times 5x squared is negative 5x squared, and then we must multiply it by both. What's negative 1 times negative 3x? Positive 3x. I'm going to put just a squiggle there so we see that these are two problems. So now that I've gotten rid of the parentheses, I'm ready to just combine like terms. Hey Adam, what are my like terms? Which ones could I add together?
2x squared minus 5x squared.
2x squared minus 5x squared. So what are the other ones, Liam? Positive 3x and negative 5x. We add those together, we get negative 2x. And then we have plus 7. If anything adds to be 0, we just cross it out, that cancels out. Multiplying is different. Multiply, we can let the stuff inside the parentheses interact. So we distribute 2x times 5x squared. When we multiply those together, we multiply the coefficients. 2 times 5 is 10. We add the exponents, x to the first plus x to the second, so 1 plus 2 is 3. Then we multiply again. 2x times negative 3x is negative 6x squared. Now that we've multiplied the 2 by everything in the other parenthesis, we go to the negative 5. Negative 5 times negative 5x times 5x squared is negative 25x to the third. Negative 5x times negative 3x is positive 15x. Now, normally we would continue this on the same line, but I'm running out of room, so I'm going to write the rest of mine underneath. 7 times 5x squared is 35x squared. And 7 times negative 3x, oops, this one, is negative 21x. So the addition and subtraction and the multiplication end the same way. We get rid of the parentheses differently, but once the parentheses are gone, I still combine like terms. So what will 10x to the third combine with?
Negative 25x to the third.
Negative 25x to the third. So we get negative 15x to the third.
And then -6 squared plus
Negative 6 plus 35 would be 29x squared. And then 15 minus 21 would be negative 6x. So the problems looked almost exactly the same, but we have completely different answers. So we did addition and subtraction of polynomials, and then we did a whole bunch of factoring. But it really boils down to being able to do two types of factoring. So when we did factoring, we always had one first step that was the same for any type of factoring. What do we always do first? Greatest common factor. Every single time. GCF with every single factoring problem. You must do that first. Then we had some options after that. So our first option depends on the number of terms. If we have 2 to 3 terms, we used one method. If we had 4 terms, we used a different method. And if we have 5 or more terms, we're just done after greatest common factor. We can't do anything else. So if we have 2 to 3 terms, I can use the box method. If I have 4 terms, I can use the grouping method that we learned last time. So 2 to 3 terms, I can use the box method. 4 terms, I can use grouping. So when we started the box method, we started by multiplying first by last. And that's the common step that people skip. They often forget to multiply first by last. And then they think it's unfactorable because none of the factors will work most of the time. So we can't forget that step or it screws up the rest of our box. We found factors of the product. That add to the middle term. Sometimes there is no middle term. That's when we have 2 terms. So if there is no middle term, we use 0. They still multiply to the same product, but they add to be 0. So after we found those factors, we could set up our box. I'm not going to write the whole way to set up the box. I'm just going to say set up box. We greatest common factor again, and we write our answer. When we greatest common factor again, we greatest common factor every row, every column, and then what we get on the outsides was how we wrote our answer. So we can do box method for most of our factoring. There were some different options, but then you have to remember all the different variations. So I focused on box method because you can use it every time, even though there are some variations that make it a little quicker. If you do the same thing over and over again, you're more likely to do it correctly instead of forgetting some of the different variations. The only one we can't use box method on is when we do factoring by grouping. So when we do factoring by grouping, we've already greatest common factored. That was our first step for either. We formed our groups. This one has a lot less steps. We GCF again with each group, and we write our answer. So there's a lot less steps on factoring by grouping. So while you finish writing those down, I'm going to pass out the review assignment and possibly shut the door. That's kind of loud enough. And then we're going to go through 3 problems on the review assignment together. And then, like I said, the rest of the time will be for you to work on the review assignment and ask me any questions you may still have before we take the test.
Are we taking the test today?
Yes.
Oh. Yeah.
We're taking it today?
Yes, I was lying.
Wow.
Yes. Yes, you may. I'll pass it back. So does everyone have this written down so that I can go through the problems I want to talk about? So number 1. What are the instructions on number 1? That's very important that you read the instructions. What does it ask you to do?
Classify by degree.
Classify by degree and number of terms. I did not ask you to factor. This problem is much easier because all I'm asking you to do is classify. Tell me if it's first, second, third, fourth, fifth degree, whatever degree it happens to be. Tell me how many terms there are. How do we tell what degree a polynomial is? The highest exponent tells us. So what's the highest exponent on this one? 2. So second degree. And then how many terms are there? 3. So second degree, 3 terms. That's our answer. That's all we were looking for. So make sure to read the instructions. Otherwise you might go through and try to factor, which is a lot more work. And you wouldn't get any of the points, even though you did all that work, because it wouldn't be what I was asking for. So I also wanted to look at 8, and then one of the factoring problems on the back. Thank you. So r plus 8 times 6r minus 2 times 2r minus 7. When we have multiple things multiplying together, we multiplied the first 2 together first, and we ignore the third one for now. So we know how to multiply 2 binomials together. It's the rainbow method. So we multiply r times 6r, 6r squared, r times negative 2, negative 2r, 8 times 6r, 48r, and 8 times negative 2, negative 16. If we do have like terms, we combine our like terms. Which ones are our like terms? 2 and 48, and 2 is negative, so negative 2 plus 48 is 46r. We do leave this in parentheses. Normally we can let the parentheses go away, but since this third one still has parentheses, I cannot just let the parentheses go away on this one. So we just bring the third one down, and now we would multiply again. Now we would do the rainbow method a second time. So I'm going to let you guys finish the rest of the problem on your own. It's just rainbow method a second time. So last problem I want to talk about is number 14 on the back side. So what do I always do first with any factoring problem? GCF. So what divides into both 2x squared and 200, Aaron? 2. So I would divide both of these by 2. We get 2 parentheses. 2 divided by 2 is 1. 200 divided by 2 is negative 100. Again, that division is something you could use your multiplication table to help with. Not on all of them, because it only goes so high. But multiplication tables can also help with division. So now we have to decide, are we going to use box method, or are we going to use grouping? So we count. How many terms are there in the parentheses? 2. What method do we use if there's 2 parentheses? Box method. So we multiply first times last. 1 times negative 100 is negative 100. So I'm looking for things that multiply to be negative 100. What should they add to be? They always add to be the middle term, and I heard someone say it, 0. Okay. They add to be 0. So we want things that multiply to be 100, add to be 0. So what are some things that multiply to be 100? 10 and negative 10. What else could I have used? Negative 50 and 2. And then negative 101. But we look at it and we know negative 10 plus 10 is 0. So those are the factors I'm going to use. We make our box. First term goes in the first box. Last term goes in the last box. Darius, I only need you to be quiet for like 2 more minutes. Please quiet down. Yes, you can. What do I do with the 10 and the negative 10? What do I use those for? The other 2 boxes. Thank you, Dylan, Taylor, and Aaron. Oh, I don't know why I used R. We're having X's. And then we also write a variable with them. Whatever variable we're currently using, we write one variable inside as well as those factors. And then we greatest common factor. What divides into both 1 and 10? 1. They both have an X, so we use an X. What divides into negative 10 and negative 100? Why do we make the 10 negative, though?
First one is negative.
The first one is negative. Then we go down, we get 1x again, positive 10 on the other side. So now we write our final answer, 2 out front, 1x plus 10, 1x minus 10.